This problem is another problem that has both what I like to call a number equation and a value equation. The number equation referring to the number of hours that she's going to work, the value equation referring to the amount of money that she's going to earn. Clearly tells us that we're supposed to use X to represent the recreation hours and money, and Y to represent the hours at the candy store. So we're going to follow their advice. I'm going to start with the number of hours equation. So I'm working on letter A right now. So A is that X plus Y, and notice it says she's not allowed to work more than 16 hours. So this has to be less than 16. Okay? Technically less than or equal to, I believe. And then our money equation, or value equation, it looks like she can earn $8 for working at the recreation department, so we'll have 8x. And it looks like she can earn $12 an hour at the candy store, so we have 12y. And she wants to earn at least $150. So that's why we use the greater than or equal to symbol for that. So we've written the system of linear equations. And now it says to graph. So the next step in graphing is going to be getting both of these into slope-intercept form. So rewriting this will give us y is less than or equal to negative x plus 16. And if you do the math, I think I did all of this right, you should end up with y is greater than or equal to negative 2/3 x plus 25/2. Now, if you're not able to do all of this, getting from here to here in your head, getting from here to here in your head, you should definitely show your work for all of this, because the practice for you is good, and you will not always have me there to do all the translating into slope-intercept form. Now, it says graph a system, so this needs to go onto graph paper, and I expect you on this particular one to do it manually. On test 9, you're going to have a question that is going to require you to manually graph, not using your graphing calculator. So in order to prepare you for that, I would like you to graph this one manually as well. Okay? I'm not going to do that for you. You're going to do that on your own. However, I will show you that the graph, what the graph might end up looking like. And it's going to be a rather small sketch, so this is the general, this is what it will look like generally. Okay? You're going to have some kind of line like this and some kind of line like this. Okay? Now, if you shade it properly, the only place that will be double shaded will end up being right here. Okay? Now remember that that place that's double shaded is the place that will be true, that will create the true or the feasible options for her hour combinations. Okay? So it says describe the portion of the solution set that contains meaningful solutions. Okay? So my opinion is that the answer for that can just be the parts from quadrant 1. Remember, it can only be quadrant 1 because you can't work negative hours. So quadrant 1 is the only one that has positive values for both x and y. So the parts from quadrant 1 that are double shaded. Okay, now I didn't even show the shading for everything. I just showed in yellow down here the part that was double shaded. But you get the idea. I guess I should say double shaded, not double shading. Okay? So let's finish up with letter C. Determine the vertices of the polygon you described in part B. Well, we didn't even describe a polygon, did we? Well, it's a triangle, okay? Certainly it is a triangle. You can see that right here. I'll just outline that one more time. It's a triangle. And so there are 3 vertices, okay? So there's this vertex, and this vertex. Now, I'm hoping that you can see that these 2 vertices are just the y-intercepts for both equations. So, goodness, that should be pretty easy to identify. Letter C, the vertices for the first 2 are going to be 0, 16, 0, 12.5, all right? Which really both of those are options for her for what she could really minimums and maximums, I guess. I think that's what it's referring to. But then there's this vertex over here, right? Okay. So I'm recommending if your graph is hard to read and you can't tell exactly what it is, just enter these equations into your graphing calculator. You know how to do that. Now I know you still had to manually graph it, but to make sure that you get this vertex exactly right, if you enter these 2 equations into your graphing calculator, then you can use the calc feature, and then when you select calc, there's an option to choose intersect, okay? And then you can choose the right boundary and the left boundary of the intersection, and when you hit enter after you've chosen the left and you've selected the left and right boundary, it will actually spit out the x equals and the y equals values at you. And if you get the same thing I get, I'm thinking you should end up with 10.5, comma, 5.5, okay, as your 3rd vertex for this triangle. And they represent all 3 of these vertices. This one, and this one. They all represent the combinations of hours that the student could work to meet her goal. I hope this helps.